Hey everyone, this is Jillian, and now we're going to put this together. Instead of having only one step where you bring a positive over, it becomes a negative, or a negative becomes a positive, meaning you have an addition which becomes a subtraction, or a subtraction which becomes an addition. And then here you have a multiplication which when you bring it over becomes a division, just like I talked about here, and a multiplication over here becomes a division. We're going to now have more than one step. So let's take a look at how we do that. Here we have 4x plus 3 equals 15. Now, of course, some of you are going to be able to, in your head, figure out 4 times what plus 4 times something, get an answer, add 3, and it's going to be 15. But whether you can do it in your head or not, when things get more difficult later, you still need to know this process, so I'm going to teach it to you now. Anyhow, so here we have 4 times something plus 3 is equal to 15. So this 4 times something plus 3 equals 15. This 4 times something we know needs to be 3 less than 15 because we're going to do 4 times something and then add 3 to get it to 15. So we want to know what is 3 less than 15, and that's what this is going to equal. Because in this case, it ends up being 3. 4 times 3 is 12, and 12 plus 3 is 15. So if we want this to equal 3 less than this, we already know that when we bring a addition here, a plus 3, over, it's going to become minus. So let's do that. And the proper way to do it is to line up your equal signs. So now we have 15 and we're going to minus 3. So that's 4x equals 12. And then we have a question like this or this, where we've got this is multiplied, so now it's going to be divided. And 12 divided by 4 is indeed 3. So that's how you do that kind of question. Let's take a look here. Here, this is a little different than this because here there's some collecting to do. Here we're going to bring the x's all over to one side and the integers over to the other side. So this already is on this side. This x we want to bring over. We know when we bring something over the equal sign it changes from positive to negative or negative to positive. And this side already has a 7. And when we bring positive 2 over, it's going to become negative 2. Now we can collect. 3x minus 2x is 1x. We know there's a 1 there, but we don't write it. And 7 minus 2 is 5. Now, you can check to see if you've done your answer correct, if you've done the work correctly and got the right answer by simply taking x equaling 5, sub it into the left-hand side, see what you get, sub it into the right-hand side, see what you get, and then see if the left side does indeed equal the right side. So let's do that orally this time. We'll write it up another time. 5. So 3, we know that we BEDMAS, we do multiplying before we add and subtract. So 3 times 5 is 15, and 15 plus 2 is 17. So this side equals 17. Let's see if this side equals 17. So this is 5 times 2 is 10, and 10 plus 7 is 17. So yes, when x is 5, x equaling 5 makes this side equal to this side. Okay, let's go on to another one. Here we have some distributing to do. So we're going to do, this says 4 times everything in the bracket, so we're going to do 4 times that, and 4 times that. And now we have a question like we did here. We've got a minus 16 here, so we're going to bring over to this side, minus 16, and when we do, minus becomes plus. Then we're going to simplify. So 24 plus 16, if you can't do it in your head, just write it over here. 24 plus 16, that's 10. Carry the 1. 1 plus 2 plus 1 is 4. So that equals 40. And then we have a question like this. We're going to divide both sides by 8, or this is multiplying, so this becomes dividing. And of course, we know our times tables. We know 8 times 5 equals 4. There you go. Let's do another one. Here we've got this times everything in the brackets. So we've got negative 3 times, oops, what am I doing? I'm writing what I'm saying, I'm not doing the work. Negative 3 times 4 is negative 12a, and negative 3 times negative 5 is plus 15 equals 18. Now I'll leave this on this side, and I will bring positive 15 will become negative 15. This simplifies to 3. This divides, and now we have a situation like we had here where, because we know our times tables, we knew here that 5 went into 5 and 5 went into 30 evenly. Here we know 3 goes into 3 evenly and 3 goes into negative 12 evenly. So 3 into 3 is 1, and 3 into 12 is 4, and a positive divided by a negative is a negative. Okay, let's keep going. Now we have some decimals. So what? We just keep going. It's not a big deal. So here we have 0.4x equals 1.2. That's positive, so when we bring it over, it's negative. So now we have 0.4x equals 1.2 minus 2.4. Again, you do it on the side in your rough note area if you don't have if you can't do it in your head. So I know this equals negative 1.2. Now, if you don't like decimals, get rid of them. I personally prefer to get rid of decimals. I don't love working with decimals. I like working with whole numbers, integers, rounded off numbers. So I know that if I have one decimal place here and one decimal place here, I can just multiply both sides by 10. And when I do that, I get, because whatever you do to one side, you have to do to the other side because these two things are equal to each other. So this times 10 is that, and this times 10 is that. Doesn't that look a lot easier? I think it does. Anyway, so now I'm going to, this is 4 times x, so now I'm going to do on this side divided by, and I know that 4 goes into 12 evenly 3 times, and a negative divided by a positive is a negative. Okay, here what I'm going to do is I'm going to get rid of my decimals before I do some work. You can do it this way, or you can do some work with decimals and then get rid of them. It doesn't really matter. I'm just going to do this another way so that you can see they both are fine. So here, this is 1 decimal place, this is 2, this is 2. So I have to multiply by 100, or a 1 with 2 zeros to get rid of 2 decimal places. So if I multiply this by, and I move this 2 spaces, this is going to be 210 plus 15 equals, multiply that by 100, because that's a 1, and multiply this by 100 is that. Now I have no decimals. I'm going to do exactly what I did up here. I'm going to bring the x's to one side and the integers over to the other side. So I have 210x, that's positive, so when I bring it over it's negative. Oops, I missed a 0. And then I have 345, and that's positive, so when I bring it over it's negative. And 210 minus 100 is 110. And 345 minus 15 is 330. So now I'm going to do x is equal to 330 over 110. And now I have to reduce. So first of all, we know that when there's a 0 over a 0, you can just cancel them. And now we have 33 over 11, and we know that 11 times 3 is 33. We're done.